Hi everyone, I am Selva. In this one, we will try to understand what is feature encoding, what is the need for even doing feature encoding in machine learning, and the different types of feature encoding approaches and how they actually work. We will try to explore all of these aspects in this one. Now, most machine learning algorithms, we will be using various different machine learning algorithms to train our models. Now, most of these algorithms like linear regression, neural networks, these kind of algorithms, they can understand numeric data. If your data has numbers, they can understand them. But if you have text or some categories inside your data, you need to be able to convert that kind of a data into a numeric format in order for it to be consumed or used by the machine learning models. This part where you are encoding a categorical or a text data to a numeric form is what we typically refer to as feature encoding. Alright, take a look at this. You have country data, you have the rating data, countries such as say you have the Canada, US, India and all these countries. For the machine learning algorithms to use this data, you need to convert them through some technique into a numeric form that will represent these, that will in turn represent these countries in a meaningful way. Alright, in a manner that the machine learning algorithms can use that data. Alright, like that, ratings also, you have good, bad, best, these kind of ratings is present, you need to be able to convert them into numeric format. Various different approaches exist. So on the right hand side, we have various different approaches. We have the label encoding approach, one-hot encoding, frequency encoding, ordinal encoding and target encoding. Let's look at these approaches one by one. Alright, so first label encoding. Now here, the name label here should give you a clue. Okay, the response variable, which we typically write it as y, is also called the label, simply called as the label. Here this is a made up data. What I have tried to represent here is on various days of the week for various weather conditions, temperature conditions, either cool, warm, hot, and there are only 3 days of the week, Monday, Tuesday and Wednesdays. Alright, whether the children are playing on those kind of days and temperature combination or not. Alright, so you have this kind of a data here. You have this kind of a data here. And typically, if you want to use label encoding, we will use this kind of an encoding only on the label data, not on the text data, not on this data, not on, let me use a different color, not on day, not on temp, right? Not on the x variables, only on the labels, right? Typically, what will happen here is we will convert the non-playing as zeros and playing days as ones. This is what label encoding does. If you have another category here, let's say you have a third category, you will write it as not play here. If you have a third category, suppose, you will write it as say 2 and so on and so forth. That is what is typically referred to as label encoding. It's not so useful. We will use it on labels alone, not so popular as such. Alright, so that's what label encoding is all about. People still make the mistake of using label encoding on features, which is not the right thing to do. Okay, the next approach, say you want to transfer or encode or transform, say the day of the week, right, this kind of a data into a numeric form. You can very well use the one-hot encoding based approach. What this does is, say you have the days of the week, we will create as many binary columns. Binary columns means the values, it can hold values ones and zeros only. Alright, so we will create as many columns as there are categories in the data. Right, say we have created a column for Monday, Tuesday and Wednesday, 3 different columns. For the Monday column, it will have the value 1 whenever the day is Monday. So these 2 places alone, it will have 1. Likewise, Tuesday will have 1 whenever it is a Tuesday. Same for Wednesday. Now typically what happens is for algorithms such as linear regression and all, right, for linear regression and all, we will not create as many columns. We will create 1 column less. So you have 3 possible categories in the data. We will create 2 categories only, because the Wednesday here, the information that Wednesday contributes is provided by Monday and Tuesday itself. So if you put a formula, Wednesday is nothing but 1 minus Monday minus Tuesday. Right, for any of the rows in this data, if you subtract Monday plus Tuesday value, so add these 2 up, add Monday and Tuesday up, and subtract it from 1, if you do that, you will get Wednesday's value, right. So since this information contributed by Wednesday has already been available in Monday and Tuesday, we will typically not create this column at all in the first place in case of linear regression like algorithms. Yes. So this is one hot encoding. This is a nice way of representing your categorical data into multiple different columns. Very useful. Still used today. Yeah. The third approach is frequency encoding. All right. Very similar to the previous approach. Instead of having ones and zeros, you will replace these values wherever it is 1. You will replace these values with the frequency of occurrence of these values of the respective categories. For example, Monday occurs 25 times and Tuesday occurs 40 times. What you will do is you will replace the 1 with, let me use a different color, 1 with 25, and here also you replace it with 25, right? And wherever it is Tuesday, on Tuesdays you will replace this value with 40. With 40, you will not create as many columns here, just one column. You will replace Tuesdays with 40, and Wednesday occurs 35 times, right? So this will be 35. This is nothing but frequency encoding. Now this is also not commonly done. This might be useful in cases. You need to understand the context whether it will be useful or not. If the situation is, if suppose you are trying to predict a particular variable, all right, some variable, imagine one variable. If that variable, if say this is a numeric variable, the value of that variable increases as this value increases, this frequency count increases, right? Tuesday having a higher value of 40 means the chance that the y variable will be equal to 1, right? Y variable will be equal to 1 increases as this value increases, right? This sort of represents the probability of the y taking a value of 1, right? If these represent that kind of a probability, then this might be useful, which is not the case in most situations. So people normally don't use frequency encoding, don't use it unnecessarily. All right, but still, if you feel okay, there's a higher, so Tuesday is having 40, so whenever it is Tuesday, there's a higher chance that the children might play on Tuesdays. If that is the case, this might be helpful. Yeah, so that is frequency encoding. Fourth one is ordinal encoding. So if there is an intrinsic ordering within the data set, so here we have good, bad, poor, and outstanding, right? So here say you might want to, there's an internal ordering to this. If you think about it, so poor might be 0, right? Poor might be 0, bad might be 1, good might be 2, and outstanding might be 3. There's an internal ordering to this. So you can replace wherever there is bad, right? You can replace all those values with 1. Wherever there is outstanding, you can replace all these values with 3. This way also you can do encoding. Since there is an internal ordering, we call it as ordinal encoding method. Alright, so we have covered 4 different methods. The fifth method is a very much more powerful method, which is the target encoding. There's a lot to be said about target encoding. So this particular topic we will cover in its own video. Alright, we'll have a dedicated lesson for target encoding and understand this method in a lot more detail. See you in the next one.